Hi everyone, I'm Shubham Jhanwar. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2018 Paper-1 Mathematics, and the question for this video is this. Let A, B, C be three non-zero real numbers such that the equation root 3a cos x plus 2b sin x equal to c, where x is supposed to be between minus pi by 2 closed to pi by 2 closed, has two distinct real roots alpha and beta, with alpha plus beta equal to pi by 3, then the value of b by a is what? Now this question can be approached in different possible ways. We are going to see two ways of solving this question. First approach is based on the thought that let me write sin x and cos x in terms of one unique variable. For example, sin x and cos x can both be written in terms of tan x by 2, and let me create an equation in tan x by 2 and solve it. Cos x is 1 minus tan square x by 2 divided by 1 plus tan square x by 2, and sin x is 2 tan x by 2 divided by 1 plus tan square x by 2. Let me straight away take tan x by 2 as t and write the equation. So upon writing cos x and sin x in terms of tan x by 2 and taking tan x by 2 as t, and upon rearranging, I essentially get this quadratic. Now this equation is a quadratic in tan of x by 2, and the roots of x in the interval minus pi by 2 to pi by 2 are alpha and beta, and they are distinct. So it is also given alpha plus beta is pi by 3. So I may say alpha plus beta by 2 is pi by 6. The reason for considering alpha plus beta by 2, which essentially is alpha by 2 plus beta by 2, is because we have a quadratic in tan of x by 2. So I can say the roots of this quadratic are tan of alpha by 2 and tan of beta by 2. And since I know alpha plus beta by 2, I may consider tan of alpha plus beta by 2, which will be tan of pi by 6, which will be 1 by root 3. Now we know tan of alpha plus beta by 2 is tan of alpha by 2 plus tan of beta by 2 divided by 1 minus tan alpha by 2 tan beta by 2. And the moment I see tan of alpha by 2 plus tan of beta by 2, I would say it is sum of roots of this equation in t, because t stands for tan x by 2. And tan alpha by 2, tan beta by 2 essentially is the product of roots of this quadratic in t. So sum of roots tan of alpha by 2 plus tan of beta by 2 is equal to minus times coefficient of t divided by the leading coefficient. We get this. And tan of alpha by 2 multiplied by tan of beta by 2 is constant term divided by the leading coefficient. We get this. Upon expanding tan of alpha plus beta by 2, as per the formula tan alpha by 2 plus tan beta by 2 divided by 1 minus tan alpha by 2 tan beta by 2, and then using sum of roots and product of roots, we essentially get this upon rearrangement. Now here c gets cancelled out, and what I get is 4b by 2 root 3a is equal to 1 by root 3. Root 3 cancels out, 2 cancels out, and the value or the expression that we want b by a turns out to be half, and that's my answer. Now let's see another approach. As you see the question, and as it has been asked the value of b by a, you may feel free to divide this equation, this whole equation, by a, because definitely a would not be 0. And you get root 3 cos x plus 2 times b by a, the expression whose value you want. Let's call it, say, k, times sin x is equal to c by a. Let's call it d. Now since alpha and beta are roots of this equation in x, so x equal to alpha and x equal to beta would satisfy this equation. So you essentially get two expressions, one in alpha, one in beta, by putting x to be alpha and x to be beta respectively. We get root 3 cos alpha plus 2k sin alpha equal to d, and root 3 cos beta plus 2k sin beta equal to d. Now as I subtract to remove d, because ultimately I am interested in k, so I get root 3 times cos alpha minus cos beta plus 2k times sin alpha minus sin beta, and d minus d becomes 0. Now here cos alpha minus cos beta, we know using the formula we get minus 2 times sin alpha plus beta by 2 sine alpha minus beta by 2. And sine alpha minus sine beta, again using formula, we get 2 times sine alpha minus beta by 2 cos alpha plus beta by 2 equal to 0. Now we know alpha plus beta is pi by 3. So alpha plus beta whole divided by 2 is pi by 6. Sine pi by 6 is half. So I'm left with this. And cos pi by 6 is root 3 by 2. So I get plus 2k multiplied by root 3, because 2 times cos alpha by 2 would become root 3 sine alpha minus beta by 2 equal to 0. Now clearly we can take root 3 sine alpha minus beta by 2 common, and the other factor would clearly be 2k minus 1. So essentially I get this equation root 3 sine alpha minus beta by 2 times 2k minus 1 equal to 0. Now here root 3 definitely would not be 0. So only two possibilities are maybe sine alpha minus beta by 2 becomes 0 or 2k minus 1 becomes 0. Now here the benefit of the question, since the value of k has been asked and that should be determinable, there should be some answer there. So given the objective format of this exam, one may unscrupulously say कि k तो half हो गया, yeah, you may say कि k is half, but a scrupulous student would want to check कि यार, can I say कि sine alpha minus beta by 2 would never be 0, would not be 0 given the conditions in the question. So let's explore. So here alpha and beta both belong to minus pi by 2 closed to pi by 2 closed. So alpha minus beta would belong to minus pi close to pi closed. Now you may wonder how. Because alpha belongs to minus pi by 2 close to pi by 2 closed and beta belongs to minus pi by 2 close to pi by 2 closed. Alpha minus beta would be minimum when alpha is the minimum possible and beta is the maximum possible. So minus pi by 2 minus pi by 2, you get minus pi. And alpha minus beta would be maximum when alpha is the maximum possible and beta is the minimum possible. So pi by 2 minus pi by 2, it's pi. Now here we are concerned about not alpha minus beta but alpha minus beta by 2, which will belong to minus pi by 2 closed to pi by 2 closed. Now for sine of alpha minus beta by 2 to be 0, given that alpha minus beta by 2 is between minus pi by 2 closed to pi by 2 closed, alpha minus beta by 2 should be 0. That means alpha should be equal to beta for sine of alpha minus beta by 2 to be 0. There is no other possibility otherwise for sine of alpha minus beta by 2 to become 0. And even this possibility is rejected. Why? Because it is given that the roots are distinct. These two roots alpha and beta are distinct. So that means root 3 can't be 0. This expression also can't be 0. So the only possibility is 2k minus 1 becomes 0. That means k, the value that we want, we get as half. So we have seen two methods and we have solved in a varieties of ways. Thanks for listening. Stay tuned for the next question.